Hello everyone. So this is another MathCON video. We have a geometry problem. So this is a grade 9. Okay. So we are given a rhombus and the point E and F, like this point and this point, are the midpoints of the sides. And EF is given 10 and AF is 13. So based on that, we are looking for the area. So, if you want to find the area of a rhombus, you really want to know about like the diagonals, which is you do not have it right now. But if I really want to kind of connect these two, that will be my diagonal. And at the same time, this triangle right here and this triangle right here will be similar. The reason why they are similar, since this is midpoint and this is midpoint of these sides. So, and the angle right here is C is the same in this triangle as well as this triangle. So, which is why the one angle in this triangle and this triangle are equal, which is angle C. And the ratio of this side EC to ECD is 1 to 2. Ratio of CF to CB is also 1 to 2, which is why this triangle and this triangle are similar, and the ratio of similarity is 1 to 2. Okay, and since this is the third side of the smaller triangle, and this is the third side of a larger triangle, so this guy to this guy is also 1 to 2. From there, I can say dB is gonna be 20. Okay, so let's keep this in mind. And this next thing that I'm probably gonna do is just basically connecting this vertex to the other vertex so I can get another diagonal. And since we have a rhombus, which means DC and CB are equal, which makes this 90 degrees because we have isosceles triangle for this part, okay? So this is gonna be equal. And I do know this was midpoint, this was midpoint. So this point is also midpoint of this height. So that is something, as well as this is the half of, like, this guy will be half of EF. So which is why this is 5 and this is also 5. Okay, so we did not use this 13 yet. Okay, so at the same time, I should have this information. This guy is parallel to this guy, which is why this is also 90 degrees. And if you are not convinced yourself, well, why this is 90, why this is parallel to this guy, just remember the similarity. And this is 5, and then AF is 13. So if you take this triangle as a right triangle and use the Pythagorean, you can find this distance. So if I call maybe this is H, so AH squared plus 5 squared is 13 squared. So if you solve this equation, so you will get A squared is 169, and this is 25, subtract from both sides. So the AH is gonna be 144, but that's square. So the AH will be 12, okay? So this is 12, but some of you, I hope all of you, already know the Pythagorean triples, which is why we don't really need to use this Pythagorean at all. So our first Pythagorean triple was 3, 4, 5, which is like 3 numbers that satisfy the Pythagorean, is called Pythagorean triple. And the second common one was 5, 12, 13. In our case, since this leg is 5, the hypotenuse is 13. So this leg has to be 12, which is actually what we've got right here. So if you remember this triple, so you don't have to do this much work, okay? Anyway, so this is 12. And I do know this point right here was the midpoint of this height. So if I call this guy is X, so it's CH, then maybe if I call this is TH is also X, because this was the midpoint. And this distance is 2X, and from this point to this point, it has to be 2X as well, because this is the rhombus. So this piece, same as this one, diagonal intersect each other like at the midpoint. So we know AH was actually 12, which is what we got. And that is 3X is 12. So the X should be 4. So as soon as we have this is 4, so we are almost done, right? Because we know this is 4, this is 4. That means this diagonal is 8. So, I mean, this part of the diagonal is 8. This is also 8. So AC is 16. So AC is 16, and we already know BD was 20, and you can just find the area of the rhombus by taking the half of the product of the diagonals. So the area is equal 20 times 16 over 2. So cancel 2, so you will get 160. Again, that's the area of a rhombus. You just multiply diagonals and take the half. But if you don't remember that, so you can maybe find the area of the triangle separately and add them together, because we know 2x is gonna be 8. So like this is gonna be 8, and this guy is gonna be like 10 because BD was 20. So if I wanna find the area of the triangle, so 8 times 10 over 2, that will give you 40. But we have those 4 of those triangles, so that will be 160. So this is one way to do this problem. So I hope that makes sense. So if you can find some other ways, so go ahead and try and let me know if you have a better solution than this one, okay? Good luck, and I will see you in the next video.